Hey guys, um, yeah, today we will about quick review about capacitors property and the previous lecture. I what I didn't express the some part. I will also explain more, and we will learn about why capacitors act as a reactance. In the circuit. Let's look at it. So first of all, as you guys can see, we have to memorize this equation first. I will explain more about it. And the capacitor is, made of two metal plate, like a conductive plate, and beside them there's dielectric. Dielectric and insulator is, same material, but the purpose is the differences, right? This is the symbol, and because of the displacement happen, and then the current is can flow. I'll explain. So what I wanna say is first of all, yeah, capacitor. This is V. So look at that. First of all, the capacitor is open circuit, right? Like same material as an insulator, right? But as I said, explained the I, T, dt, dv. This is T. So time goes by, V is changing, the I current is, can follow, right? So this is, we say this part, transient state. So this time, yeah, the voltage is change, right? That's why the current is, can follow this part. And of course, this part, look at that. The V is no changing, right? So that's why the current is, zero, this part. So this part we say steady state and non-conductor part. And this is a conductor part. This part is a non-conductor part. And look at that. Depending on the slope, right? The current is, the size is, the magnitude is, selected depending how much, fast or magnitude of the voltage is changing in it, make it current as, values. You know what I mean? So, yeah. So, yeah, that's it about the quick review about the capacitor. And you guys know the impedance is made of the R plus JX, reactance and resistance. And stop and a little bit, think a little bit. What's the common part and what's the differences? Yeah, resistor is and reactance is same part is, interrupting the current flow, right? As a resistor, right? But the differences is R is actual user, so we say active power, and JX, reactance is we say reactive power. So what I mean is, for example, R resistor is, for example, I gave him the money, he spent it, right? So it's the same concept. If I use it, it's gone. So which means it's, the money is gone. So it's gone. We actually use the energy, and I lost, the money, right? I spent money. It's gone. So electrically, its loss is by the heat, right? But instead, the reactance is, I gave you money, I store it. I actually don't use it, didn't use it, and I return it back like this, He gave him, I return it back. We say this is reactance power, and this, combination is, we say, impedance, right? So let's see here. Yeah, this part I will explain first. Okay. So guys can see first part. Oh yeah. First of all, we need to about the, you guys know about the overcurrent. Overcurrent. Overcurrent is, there's a rated current, right? It's a, bigger than the rated values, right? So we say overcurrent. So there's a 1, 2, 3. So first of all is as we know, fault current, like a short current, right? In the circuit, the shortest happened and almost the resistance is 0, right? Almost. So it's the current is really, gonna be the size is really a magnitude, right? And second is overload current, which means we use too much of the load. Like for example, sometimes in the summer, like every house is like, for example, if we live in the condo, every house use air conditioner, right? So we use too much energy, right? So the circuit break open the circuit because you guys too much use the current, load. That's why the current is, kind of getting, tired. You guys too much you guys over already the late current. So it's, yeah, that situation we say overload current. And the last thing is transient current. So transient current, as you guys can see, suddenly, you know what I mean? Not stable, you know what I mean? Suddenly it happened, you know what I mean? We already learned about transient current. For example, one is transformers inrush current. We already learned, right? Inrush current is happened, in the state, transient state, the inrush current happened, right? And second part is later we will learn about motor. So when you start of motor, there's locked current. So the curve is like is here, the current I. So this part is locked current. It's really big, That's why we use many methods to reduce the locked current. We will learn about the motor part, so don't worry about it. And the third part is a capacitor bank. When you put the capacitor bank, the also, transient current is happen, kind of big surge current is happened. So as you can see, I, T, 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 V, T. Time goes by, V is changing, the I is current. But depending on the V's value, the I is, gonna be selected the values, right? So that's why, yeah, that is yeah, we will learn about it later. So don't get panic about it, okay? So now we will learn is about what I wanna give a second. So the last thing what I wanna explain is here. So what I wanna explain is a reactance. It's here, impedance. You guys can see. And J is imaginary number. So for example, so this equation I said constantly, we have to memorize, right? So it will be differential. So as you guys may remember, dt d is we could explain j omega, and omega is angular velocity, right? And omega we could say g 2 pi f. This is frequency. That's why this is. We mostly we see this, formula, right? 2 pi fc, right? So actually this is from the get it this number. So I explain how we get it, right? So I explain I equal C as I said, dt at d is j omega, right? And v. And as you guys can see, we have impedance, right? We now don't have a resistance. So for example, R is I, V. So which means the same meaning now, because we don't have only this resistor part, right? So if we move to here, so I, V, C, omega, J, J omega, we could get it, this, right? And as I said, J is make it 90 degrees, lead, right? For example, if it's if it's a sine and make it cosine like this. So which means, if it's a sine and make it cosine, which means if we do differential, which means J is gonna be making 90 degrees and make it more lead, So this time, that's why the I is 90 degrees lead and V is lagging. We say, look at that, this curve. I'll explain how we, recognize the lead and lag. Okay, don't worry about it. So we get it this part, right? So if we multiply JJ here, so JJ is minus 1. So minus 1 omega C and J, right? So we will say just minus J. Yeah, we say okay, minus J omega C. Here's minus J. Yeah, we do it this equation, right? But as you guys can see, here's the minus J, right? So as you guys can see, here is a real number, but we don't have it right now, right? This is J and this is minus J. So that's why minus J, I said this part here, this part, what I'm saying is capacitors, imaginary numbers minus J part. But instead, the inductors, J is here, right? Oh yeah, and I forget, sorry about guys. So look at it, guys. I explain how to lead and lag. Here, voltage is a red and current is, you guys can see, black, right? And really look at that. I said J is making 90 degrees more faster, which means lead, right? Now I said lead and V is lag, right? So look at here. Compared to peak to point, you can see this is between them is 90 degree. Okay, but which one is faster? The current black is faster, right? And compared to also these two parts, compared. Current is black, right? Current is faster than voltage. Voltage is lagging, right? So we will say this is a lead and lag. Yeah. Yeah, I guess yeah, today's lecture is done. Just remember, what is the capacitor's property and how we get this equation. Actually, you don't need to memorize this part how to get it. Just remember this equation. If you guys understand this part, you don't need to memorize about the capacitor, right? Yeah, today's lecture is done.